Hey guys, we need to keep pace. Hope you watched the intro video and got to fill out that survey. Looking forward to working with you guys. So we are going to start off with solving systems of inequalities. You have these notes online. I'm just going to go over them, and unfortunately my printer kind of cut off a couple things, so I had to fill those in. But your notes should be complete. And then the only thing that you really have to fill out on here is the example problems when we go through them. Okay, so we're gonna start with the objective. So to solve a system of, the objective is to solve a system of linear inequalities by graphing. Essentially, it's just gonna be the same as graphing a normal, like y equals mx plus b line, but we'll have an inequality in there, and then you're either going to shade above the graph or below the graph, and then you're going to see where it overlaps with the other one. If that sounds confusing now, don't worry, it's not too bad. Okay, so we've got some steps here. The first step says to make sure that y is by itself and on the left-hand side. So just like in this example, y is by itself and it's on the left-hand side. Second step is going to be to graph the inequality just like you would a normal equation. From the previous example, our slope would be 2 and the y-intercept would be -5. If your inequality has a greater than or equal to or less than or equal to line, the line will be solid. If your inequality has a greater than symbol or a less than symbol, it'll be a dashed line. Just like when you were working with like open circle, closed circle, when you had like just inequalities of one variable. Same kind of idea, except the line's going to be either solid or dashed. And then the last step is to either shade in the top half or the bottom half of the inequality, and then see where those overlap. Wherever those things overlap, that's where your solution is going to be. So let's take a look at the first example. So step one, make sure y is by itself. That's good for this one. It's also good for this one, so we can go ahead and graph this. So let's see. When I graph this, I'm going to go to my y-intercept. So I'm going to go up 1, 2, 3, 4. I'm going to put a dot here, and then -x. So remember, there is a invisible 1 right here, and that invisible 1 is going to be our slope. So -1 is going to be our slope. If you don't remember, you can always put your slope out of 1. So this is our slope. And so, and also if you don't remember, it's always rise over run. So we've got a -1 rise, which means we'll go down 1. And then we have a 1 run, which means we'll go this way. And we'll just keep going. We'll go down 1, over 1, down 1, over 1, down 1, over 1. Keep filling that out. And if you notice, this is a, there's no bar under it, right? So we want to do a dashed line. So maybe if I write over here, let's say this one and this one, you get a solid line. And these two, you get a dashed line. So we've got no bar underneath, so this is going to be a dashed line. If you have a ruler, it's preferred, but I don't have one on hand right now. So this is my dashed line. This is the line y is greater than -x plus 4. All right, so we got that one down. Let's go ahead and graph the next one. So the next one is this one right here. So my y-intercept is 2, so I'm going to start here at 2. And then my slope is 2/5. So this is my rise over my run. So I'm going to go up 2, so 1, 2, and then I'm going to go over 5. So 1, 2, 3, 4, 5. So I've got these 2 points that I need to connect. And is it going to be dashed or solid? Well, it's going to be a dashed line because of this guy right here. So we can make a dashed line in between that. And ta-da. Okay. So now we just need to figure out, we need to shade either the top or the bottom part for each of these. I think the easiest way to do this is to just try a point. So I like to try 0, 0 because it's the easiest. So if we try this point right here, this is point 0, 0, right? So I can plug that in for y. So this is your x, right? This is your y. I can plug those in and we can see if this point is in the solution set or not. So let's do that over here. We've got y, I'm just rewriting it for now, x plus 4. I'm gonna plug in 0 for y. I'm gonna plug in 0 for x plus 4. So 0, and then we've got is greater than negative 0 plus 4. Well, that is just 4. So now you gotta think to yourself, is 0 bigger than 4? Well, no, it's not. So that means that this is not in the solution set. So that means that we wanna shade everything that is up top. So I'm gonna do it lightly for now, and you'll see why in a sec, but everything up top is, everything above here is what makes this true. So if you were to try a point like 4, 4, let's try it. So if I plugged in 4, 4 instead, I would have 4 is greater than negative 4 plus 4. 4 is greater than negative 4 plus 4 is 0. Is 4 bigger than 0? Yeah, so that checks out, that works. Let's plug in 0 for this guy now. So I'll have y is less than 2/5 x plus 2. And if I plug in 0, I get 0 is less than 2/5. This will be times 0 plus 2. And this time 0 just goes to 0. So 0 plus 2, 0, 0 plus 2 is 2. So is 0 less than 2? Yeah, it is less than 2. So we know that the point 0, 0 for this guy is actually in the solution set. So we're gonna shade everything below this line right here. So I'm gonna shade everything below this line right here. And do you notice where they, I'm gonna shade everything below this line right here. And do you notice where they overlap? Well, they overlap right here. So this part, this part where we can just shade in, this is the part we care about. This is where, and this kind of goes on forever that way. This is the area, this is where, these are where all your solutions are for these two specific inequalities. So then that's how you graph it, you shade it. So then is the 0.53 a solution? Well, let's take a look. Well, we've got, let's go over 1, 2, 3, 4, 5, like about right here, and then go up 3. So it's like right here. So is that in the solution set? Yeah. So we can write, is this point in the solution? Yes. All right, I'm gonna pause the video and then I'll do 2 more examples in the back.